video is on total floats and free floats. I'll just abbreviate them like that: total floats and free floats. So I'll start talking about them one by one. And by the way, what we're going to do in this video is that we'll just pick it up that you already have a network constructed, which I'm about to show you, and you have already determined your critical path and whatnot, and you're done with basically the networking problem, because this video is just being viewed like an additional to, you've already drawn your network paths as earlier seen in my other videos on networking, and now you're just trying to determine the total floats and free floats based on, of course, those determinations which we get to use when we're getting that critical path. So let me just share one particular network which is completed, then I'll start explaining from there how to get these two things. So the first one I'll start explaining will be, first of all, the free floats, then I will move to total floats, and just like that. So suppose you have a network like that, maybe node 1 there, okay, node 2, you can also have node 3, you can have node 4 there, and then you can also have node 5 actually. So then you just put, okay, activity A, activity B, activity C, D and E, something like that. Then now you have what scenario? You can have this one as well of maybe 1, okay, the durations on the axis. You can have a 3 there. Here you can have a duration of 4. There you can have a duration of 2, and there you can have a duration of what, 5. Okay, then when you're determining that critical path, right, there are those particular, did I say, structures that you create, like a house shape, a box and that heart on top, a box and the heart on top, a box and the heart on top, something like that. So it's like you redo this process. It's very key when you're using those total floats and free floats. You need these structures created already. That's the only way you can come and get them right. That one there, and finally one house-like structure as well here. So now you start putting in, of course, those figures as we put. So we got the first node. As of the first node, what would be the earliest start time? Well, just a refresher, as of course was stated in that video for critical path method, that box-like structure is where we put the earliest start time. So just like on node 1, what would be the earliest start time? It's usually 0 in node 1. On node 2, what would be the earliest start time? You follow the activity on the duration on that arc from point 1 to point 2. What's the duration? There's a 3, meaning the start time of that other one will be what? 3. That's how we just test, if anything. So in the box, we just put what? The start time, and in that triangular shape, we put the latest completion time, which I'll explain very soon. Okay, so on node 2, what about node 3? How do you get to node 3? There's that movement from point 1 to point 3. There's a duration of 1. So meaning the earliest there you can start is actually just 1. Okay, next. Then if anything, what else do we have this side? You can also have 3 to 4. 3 to 4, what would be the start time on 4? You might say, okay, we're on 1 and we're going to at point 3 we have 1, right? So it's like you add on with the activity that's going to 4. There's a 2, you would say 3, right? Another way you'd ask yourself is, at node 4, is there only one route going to node 4? No, there are 2 routes. So you test out both and then you see which one will give you the highest. So check these routes going from 3 to 4. On 3 there was a 1 plus that 2 gives you 3, right? What about the route from 2 to 4? On 2 there was a 3 initially, right, as that earliest start time, meaning going to 4 there is an activity of 4 that's along the route. So it's going to be 3 plus 4 giving you 7 as the longest one between 3 and water. So you pick the 7, if anything. What about 4 to 5? Going 4 to 5, there's only one route. So what's the duration there? There's 5. 7 plus 5. Going to 5 there, you get 12. We are on point node 4. Node 4 had a value of 7. Going to 5, there's that duration of 5 which we've looked at. 7 plus 5, 12. Completion time, how do you get it? As of the last node, the earliest start time is always equal to the latest completion time. That's what we're now putting in the heart-like structure. Or going backwards, 12 minus 5, 7. Okay, that again. What about 4? 4 to 3, we're going back. So there was a 2 there along the route. At point 4, we had the 7. Okay, so it will be like a 5 there, because like 7 minus that's 2 you're seeing there, or going backwards from 4 to 2. There was an activity of 4 there. 7 minus 4, 3. Okay, the other one, 2 minus 1, we have 2 from 2 to 1, there's a 3. From 3 you can get to 0 there. Okay, and then there's also another root going to 1, huh? This 0.3 to 1, there's 5. 5 minus 1 is what? It's 4. But when you're looking at latest completion time, we look at the answer that will give the root that gives you the least value, which is like 0. In this case, we did okay, 2 to 1 give us 0. 3 to 1 give us what? 4. We pick the least. So that's all. You've done those particular items. Now, how do you get free float? Free float, well, it's based on, of course, those same activities. As you move like from 1, 2, like this just simply means 1 to 2. What would be the free float there? What happens is that free float is equal to what? The general formula. Free float is equal to your earliest start time. Take note of this, earliest start time of ending node minus earliest start time of starting node. What does this mean? Earliest start time of completing node. What happens is that from a root like root 1 to 2, that's how we're looking at it. From root 1 to 2, which of those is the ending node? It's 2, right? Okay, then they said earliest start time of that ending node. So if you go to point 2, what is the earliest start time at point 2? 3. Then they said minus earliest start time of starting node. Okay, so the one of them is ending. So you can just write that rule. So one of them begins with earliest start time of the ending node. The other one is earliest start time of the starting node. Starting node. So basically, it's just about the understanding there. We said you look at two activities from point 1 to 2. Which of those is the ending node? It's 2. The starting node, it's 0.1. So it's like you get that subtraction. Then after you get that subtraction, then you just say minus d, which is what? Duration. Once you subtract earliest start time of ending node minus earliest start time of starting node minus the duration, and you'll be doing that for, should I say, all your activities. So let me just like compute everything, and that's basically the formula we'll use for all the activities. Activities 1 to 2, 1 to 3, 2 to, they'll be just like in groups of 2, because an activity connects to 2 nodes. That's why we'll only be going to take free floats for two given connections. 1 to 2, 1 to 3, 2 to 4, 4 to 5, until the whole network is done and we find the free floats. So it's like I've started filling these figures up. You said you connect, those are the particular roots: 1 to 2, 1 to 3, 2 to 4, 3 to 4, 4 to 5. These are the roots in your network. You are just picking them in groups of 2. That's how it is. It's like just basically how an activity is connected to, of course, 2 particular nodes. So 1 to 2, 1 to 3. Just know that you should have 2. So how do you get free float? We already stated that earliest start time of ending node on those 2 connected to each other. Which of those is the ending? In the first scenario, it's 2. Earliest start time of ending node, you look at that one. On 2 there was 3. Then minus earliest start time on starting node, there was 0 there, right? Okay, so it's 3 minus 0, 3. Then minus duration. Duration is that activity on the arc, the figure on that line connecting the 2 arcs. That's the duration. So it's like you are on 3 minus 0, 3, 3 minus 3 again, because the duration is subtracted, giving you 0. That's the 0 you're seeing there as a free float. You do the same thing for activities 1 to 3. There's 1 minus 1 there, was the earliest start time of between the ending 1 and 3, which is the ending node, it's 3. There's earliest start time with the ending node was 1. The box shows you the earliest start time. Just remember that, like a box like structure. Then the triangular part is latest completion. And then you do that. If anything, 1 minus that, 1 minus 0, 0. Okay, you have 1. 1 minus 0, you have 1. 1 minus 1, 0. That's your free float. And you go like that. 2 to 4 is 7. 7 minus 3 is 4. That again, you get your free float of 0. There's another one. The activity is 3 to 4. 3 to 4, there's 7. 7 minus 1, we have 6. 6 minus 2, there's an activity there on the arc as 2, or the line connecting the 2. So it was like 6 minus 2, 4. Next, 4 to 5. 4 to 5 is 12 as the earliest start time of the completing node, minus 7 as the earliest start time of the starting node of the 2. 5 minus 5, 0. And you're done. Free floats. It's just that straightforward. Huh? Let me just quickly erase this for the sake of now total float. So when you look at total floats, I want to squeeze the formula just down this networking diagram there. The formula is latest completion time of the ending node of the two that are connected to each other minus earliest start time of the starting node. Okay, so I want to explain all that. Latest completion time of ending node minus earliest start time of starting node. So like for example 1 to 2, which one is the ending node? 2 has what does the latest completion time? It has 3, right? The triangular shape shows you what the latest completion time. Just remember that. So it's like 3 minus the earliest start time of the ending of the starting node this time. So it's like that 3 minus the 0, because 1 and 2 are connected to each other, which is 3, minus duration. Okay, let me just put duration. Duration is very key as well, minus duration. So the latest completion time of ending node between the two that are connected to each other, if it's 1 and 2, 2 is the ending node, minus earliest start time between the two, meaning 1 will be the starting node in that case, and then minus duration, that line, that arc there, that's what the figure there is the duration. So in the first case the total float is 0. Second case the total float is like from 1 to 3. The latest completion time is 5, minus earliest start time is 0, minus duration 1, giving you a total float of what? 4. And the sequence continues just like that. Okay, so there as well there's 7 minus 3 for the activity 2 to 4. This gives you 4. 4 minus that activity 4, 0. 3,4 there. We have latest of 7, earliest on the 3 node is 1. 7 minus 1 is 6. 6 minus 2, 4. Last one, 12 minus 7, 5. 5 minus 5, 0. Okay, we are done. One thing about total float is that it can also help you identify the critical path in its own way. It's actually a measure of helping you identify the critical path. Wherever you're seeing zeros, that was where the critical path has passed by. That's just how you know about total float, if anything, and you can actually prove that. So it's just another measure to just even get to test or prove that your critical path is also correct. Total float measure, and that's this video on total floats and free floats.